and parallel. So all you really had to do was just graph it. So you kind of got an intro of it last week, which is really awesome. So this week it'll be, I think a little bit better, but we're basically going to review that stuff and just make sure you guys understand what we're doing. And Olivia, if you're looking at this and you're like, what's going on? Just let me know, and I can help you on it. So it's all good. So yeah. Okay, so we have to, we want to determine if these two lines are parallel, perpendicular, or neither. And last week we talked about two distinct ways to determine if lines are parallel, perpendicular, or neither. Yeah, oh, I appreciate that, Piper. Thank you. No, that's okay. No problem. It's not bad. Not bad. So yeah, what do you guys think? Like, what do you think it is, Malachi? Why would you say that they are perpendicular? You are absolutely correct, my friend. What about those? So Malachi looked at those equations and he's like, yeah, those are perpendicular. So he didn't even have to graph it because of this one thing that makes them perpendicular. Yeah. So we got to look at the slopes, right? And I don't have a drawing tablet yet, so I'll have to use my finger. But this slope and this slope, they are the opposite reciprocals of one another. It's got to be flipped and the opposite sign. If that is the case, if both of those things are happening, then they are definitely perpendicular. Very good. Very, very good. So let's graph them. Can you guys graph those for me, please? Can I have a volunteer to graph the first one? You can go in the participant list and raise your hand, please. Who could graph the first one? And Olivia, just so you know, what we're doing is you can take your mouse to the top of the screen and click on View Options and go down to Annotate. And as long as you don't have a Chromebook or you're not on a tablet or a phone, it should work. So if you click your mouse and go down to Annotate, that's how we're writing on the screen and all that stuff. Let me know if you can't find it. Got it? Okay, cool. Yeah. I know there's a lot of stuff to learn, but we are Zoom experts here, so we are happy to help. So, okay, what do you guys think? I need someone to graph that, please. Can I have someone raise their hand? I think if you go to more, oh, there we go, Piper. Yeah, you figured out how to do it. Very good. Piper, can you graph the first one? And then Addie, can you graph the second one? Cool. So Piper's gonna graph the first one, good. Addie's working on the second one. I like what I see here. I see a lot going on here. Just remember, oh yeah, okay, we're getting a little confused on like where to go when we're graphing. Yeah, no problem. I like what I see here. So that dot on the 2 is really good. So that tells me that that goes with this bottom function there. Oh, it's okay. It's all good. No problem. No problem. Here, I'll review this part. We'll focus on this one. So this is your y-intercept. And that's your starting point. That's where all the graphs start. So it's very good. There's a dot on 2. And then we move according to that slope. And it looks like our slope Guys, our slope is a -4. So where would I move according to that slope? What do you guys think? From that starting point, that 2. Yeah, no, we're good. Yeah, that's right. That's right. Very good. So we would go down 4, 1, 2, 3, 4, right 1. And here's where it gets confusing. We don't go down to -4. We count 4 spaces down from that 2. So 1, 2, 3, 4, and then right 1. So we're right there. And then we connect those lines. It's not terribly accurate, but we'll go with it. There we go. Cool. So that would be the second one. So Piper, what about the first one? Where would you start that one? Oh. Piper, was that you putting a dot down at the -4? Okay, that was right. That is the starting place for this one. Yeah, sorry, I forgot that it's that. Yeah, no, you're good. You're good. So go ahead and put a dot on that -4. Yeah, and then which way would you go according to that slope? Yep, up 1, right 4. Very good. And then you can go ahead and connect those lines. And this would be a really good time for anybody who's like, wait, what? I'm confused about graphing. You know, think if you have some questions, if you're not really sure. But remember, when you graph, the number at the end is your y-intercept. That tells you where you're starting your graph. And then the slope tells you how to move. So that is what we did. And you're always going to go either up or down and then to the right. Cool, very good. All right, so let's go to the next slide. Okay, so we are in week 2 of quarter 4. Today we're going to talk more about the algebra behind parallel and perpendicular lines, and then we're going to start talking systems of equations. Ooh. Ooh, ooh. So there's kind of a lot to do this week. I apologize. I had to move some stuff around when class was canceled that week. It'll get better, don't worry. But yeah, so you've got 4, I believe, Math Excel things, then one of those little Math Mindset things. Olivia, I did adjust your list, so it just should show what is due this week. So we'll start there. Yeah, I keep getting emails. Dancy Dance, yeah. So that is what is due this week. I'm going to tell you guys, there's a lot of stuff due this week. I would start today. Don't wait until later. We're going to go through it and start today. Okay? Please get it done because it'll pile up quick, and I don't want that to happen. Oh my gosh. My phone keeps, or my watch keeps buzzing. Good job, Malachi. That's awesome. Okay, so let's review talking about parallel lines. Parallel lines are lines that never, I can't dance. I can't. Not at all. I cannot. Like a chicken, is that if you do the chicken dance though? So let's review this, guys. Slopes of parallel lines are always the same. So if you have a line and you want a line parallel to that, the slopes have to match. So what is the slope in part A? of the line that we're given? Part A, what is that slope? That is an equation in point slope formula. It's negative 6/5. Yeah, very good. Very good. That is our point slope formula. Well, good. Very good. So if that is the slope of the line that we're given, what would the slope have to be of a line parallel to that line? Negative 6/5. Yeah. They have to match. What about B? What's the slope in part B? 1. Good. Remember, slope is always in front of that variable, that x. And if there's no number there, it means there's a 1 there. Okay, so a slope of a line parallel to this line would have to be what? Uno. Yep, 1. Good. And remember, we're talking parallel, so it wouldn't be anything crazy there. Okay, for part C, we have an issue. We can't just read the slope off there. Why can't we read the slope off there for part C? What's the problem with part C? It's mixed up. It's all mixed up. It's in standard form, and the y has a 4. The y is not by itself. Yeah, you guys are right. So what would I do first to start getting that y by itself? What would I do first? Move the 12x. Yeah, how do I move that positive 12x away from the left side and put it on the right side? I'm going to subtract 12x. Right. Whenever we want to move things to the other side in math, we always do the opposite. So we're left with 4y, and then what would I have on the right side? What would I put there? Because we can't really combine the 4 and the 12x, or the negative 12x. Yeah, I'm going to take the negative 12x and put it in front, and that 4 is a positive, so it stays there. Okay, now what do I do? I'm almost home free. I got to divide by that 4 to get rid of it. It's always the opposite operation. She beat ya. Negative 3x plus 4 divided by 4 is 1. So this equation turned into this equation. Okay, so that's what it really is. So what is the slope of that equation now? Now I can really easily read it off there. Negative 3. And whenever we say the slope, we would always say negative 3 because that x is the variable. And then what would the slope be of a line parallel to that line? Also negative 3. Yeah, also negative 3. Good job. Good job. Cool. So parallel lines have to have the same slope. And when you check if they're parallel, you're just checking if the slopes are the same. So what would you, sorry, I'm going to go back. What would you have to do in part B here in order to see if they're the same slope? Because part B, we can't read it off there again. So in part A, I can kind of tell that I have the same slope because I have a 3/4 and I have a 3/4. So we would say yes. That's okay. I'm with you, my friend. I'm sleepy. So those two are parallel. For part B, how can I tell if they are parallel? Ah, Emma has it. Very good, Emma. So we would take that bottom equation. Actually, we're going to end up taking both of the equations, yeah. And we're going to solve it for y. So Emma says we first subtract 15x. And we're left with 5y equals 15. Oh, negative 15x plus 50. Ah. Oh my gosh. There we go. Oh, yeah, I'm sorry. There's a lot of stuff going on there. Here, let me rewrite that better because that didn't look very nice. So we have to solve each one. I know. Yeah, I'm sorry, guys. Yeah, I was writing over there. I know. I have the same issue with my chat box. It's annoying. So we have to take these two standard equations and we have to change them into slope-intercept form or y equals form. So 4y equals 4. So Emma suggested we subtract 12x. So we're left with 4y equals negative 12x plus 4. Oh, this one's actually the same as our last equation that we did. So we get y equals negative 3x plus 1. And then we'll take that other equation, the 15x plus 5y equals 15. We subtract 15x. So we're left with 5y equals negative 15x plus 15. Oh, keep doing that. Then what do we do? If we have 5y equals negative 15x plus 15, what would I do now to solve for y? I got to
divide by 5.
Yes, very good. I got to divide. And then we see that we have a negative 3x plus 3 and a negative 3x plus 1. So are those lines parallel? Yeah, those definitely are parallel because they have the same slope. Yes. Yes, yes, yes. Okay, the main thing that might cause a little bit of confusion for your homework is you're going to have to come up with the equation of a new parallel line. Okay, so it says find the, so first we have to write the slope-intercept equation of a line parallel to the given line. So first we have to find the equation of the line that contains the point negative 3, 7 and is parallel to that one. So our first step is we have to figure out what is the slope of the line we are given. That's our first step. Okay, so our line that we are given is 7x plus 3y equals 3. Malachi thinks it's 7 over 3. Let's check it. So what do I do to check if that's the correct slope? What am I going to have to do this way? Okay, no problem. What do I have to do? How can I figure out what the slope is of that line that they gave us? Because that's my first step. Figure out what slope we're working with. Then we can come up with the new equation. We have to subtract 7x. Yeah. So I'm going to go minus 7x. And then minus 7x. Good. So then what would I be left with? What's left on the left side there? Yeah, I would then have to divide by 3. You're so right. So 3y and then negative 7x plus 3. And then I got to divide by that 3. You dazed? Too much going on? Oh, me too. Sometimes it's hard to push through. Yeah, it totally is. But we'll get through it. All right, 3y divided by 3 just gives you y. Oh man, guys, I'm with you. I'm with you, my friends. It's exhausting. So yeah, looks like we would have, is that a parental rule? -7/3 x plus 1. So that's what we would have. So now we know that the slope is -7/3. So the slope of a line parallel to this line would be, so what do you guys think? If we have this equation, that's what we're given, what would the slope be of a line parallel to that one? What would the slope have to be? Yeah, it would have to be the same slope. Now here's what's tricky, Malachi. Yeah, the slope would have to be the same. The y-intercept is going to be different. But we have to use the information they gave us for that y-intercept. So we are going to make the slope the same. So that's our first few steps. Okay, so we know we need a slope of -7/3. Here is where it might get confusing. You guys ready? It's gonna be awesome. I'm just kidding, but seriously. So now what we're gonna do is we're going to use the equation y equals mx plus b, and we're gonna come up with that y-intercept. And we have to use, because they want it to go through this point here, -3, 7. So we have to use that. So with that slope, and with my point of -3, 7, I know 3 of the variables of this y equals mx plus b. What variables do I know? Yes, Desmos is useful for this. It sure is. What variables do I know with this given information? Do we know y? Do we know m? Do we know x? Or do we know b? What do you guys think? So like we know
m.
We know m, right? What's m?
-7/3.
Yeah, -7/3. Good. What else do we know? Piper says we know y and x, and she's right. What's my y and my x? Yeah, I heard someone whisper it. It sounded good. -3 and 7. Yeah, that's right. So my x is the -3. I don't know the b. That's what I'm doing all this to find out. And then my y is the 7. Cool. Now here's where I recommend using Desmos. I really do. It helps. It just does. It makes less work for you guys. So I'll put the link in the chat. Okay, there's the link. Oh, I forgot I can't click on it. Darn it. Darn it, darn it. Right? Less work equals a better life. Hands down. All right, so let's go to Desmos. Oh no, I don't want to graph it here. Desmos. There we go. Cool, so I'm going to type in -7/3 times -3. And I get 7. So this part right here is equal to 7. Okay, then what do I do? How do I finish solving for B? Yeah. Malika, I will tell you the graphing thing is very helpful. Yeah, I'm going to subtract that 7. I want to get everything away from the variable side. So I'm left with 0 equals B. So I'm actually not going to have a y-intercept here, and that's okay. So the line parallel to that line, it's going to be y equals, I know, right? That's how it makes me mad. But it's going to be y equals, it's going to be the same slope. But if it goes through negative 3, 7, that means it has a y-intercept of 0. So that is what we're going to put. Questions on that? We'll do the same thing for perpendicular today. Okay, so we're just solving for y, and then we're graphing. Oh, and then we have to graph the 2 lines. Can someone graph the 2 lines? What was the first one we got? I think it was negative 7/3 plus 1. So if I graph the first one, let's see. It was plus 1, 1, 2. Okay, 1, 2, 3. So this is the first one. What would the second equation look like if you graphed it? There's no y-intercept, so it's going to go through the 0, the origin. What do you guys think? How would I graph this? Where would I start? Negative 7/3 x. Oh my gosh, I'm so tired. Ugh.
You start at 0.
Start at 0. You got it. We're going to start at 0, and then we're going to go down 7, right 3. Yeah. Come on, mouse. Where'd you go? Don't act all weird. There it is. There we go. Questions on that? I feel like that's a lot. Okay, which of these lines is parallel to the line on the graph? You guys take a second and see what you can come up with. Which one of those lines is parallel to that graph? D? Piper says D. You guys agree with that? Remember, read those points from left to right. Emma says C. Well, let's check it, shall we? What do you guys think the slope is of that line? What's the slope of the line on the screen? I know, me too, guys. Lucy says B. Okay, well, if it's B, and Emma says the slope is negative 2/3, so let's check that. I can start on this point on the left and work my way to the right. So I'm going to go down 2, so negative 2, right 1, 2, 3. So my slope has to be negative 2/3, and the only one that happens is C. That's the only way it happens. D is the correct slope. It's just that one's positive. So it wouldn't be D, because see how left to right my graph is going down? That means it's a negative. Ooh. Oh my gosh, you guys are right. I don't think any of them work. Guys, you're so right. Yeah, because it would have to go up to. You're so right, but none of those work because they would have to be negative. So this one's an error. My bad. What should it be? What should it be? We know it crosses at -5, and then what slope did I get? -2/3, yeah. So this is what it should be. So our crossing is at -5, and then we go down to right 3. Oh, wait, guys, I read this wrong. Oh my gosh. Guys, my brain is tired. Okay, so it's not wrong. It's just that we're finding a line parallel to that line. So this line, I know, right? I'm sorry, guys. This line is -2/3 x minus 5. So which one would be parallel to that line? That's what I want to ask. Ugh.
C.
C. You are correct. So 1, 2, 3, 4, 5, 6, 7. And then we go down to right 3. Sorry about the confusion. Yeah. Okay. Moving on. Okay, let's talk perpendicular. Sorry for that, Piper. Yeah, sorry. Did I confuse anybody with that last question? I apologize. I feel like my brain is super tired today. Oh, man. All right, take a second. Stand up. Shake it out. Shake it out. Shake it out. Okay, we won't mess up this one, I promise. So perpendicular lines. Guys, what are perpendicular lines? What are they? They're lines. What about them?
Lines that cross at 90 degrees.
Beautiful. And Olivia, you are right. Very good. Good job, Emma. You guys get an A for the day. They cross at 90 degrees. Okay, and the slopes are opposite reciprocals. So that means if one of my slopes is -4, the slope of the perpendicular line would be 1/4. So they're flipped on the opposite side. So what's the slope of part A? That's what it would have to be, Piper. Yep. That's what it's going to have to be in order to be perpendicular. But what is the slope given as? 1/2, yeah. So in order to be perpendicular to 1/2, it would have to be -2, an opposite reciprocal. What about B? What's the slope for B? -6/5. And then the opposite reciprocal, what would that be?
5/6.
5/6. We turn it positive and flip it. What about C? What's the slope for C? 1. And what is 1 flipped and made opposite? -1 is right. Yeah, very good. Good. So those are the slopes of the perpendicular lines. It's going to have a completely different y-intercept, but those are the slopes. Okay, so now we want to determine if these lines are parallel. Let's look at A, or perpendicular. I always do that. Let's look at part A there. Are those perpendicular? What do you guys think? Are these perpendicular? Piper says no. Why does Piper say no? Malachi says no. What's our reasoning behind that? It's switched, but but still positive. Yeah. In order to be perpendicular, one would have to be 4/3 and the other would have to be -3/4. So this one's a no, not perpendicular. Okay, and what do I do for part B to figure out the slopes? What would I do for part B there?
Minus 12x and minus 2x.
Yep, we have to solve for those y's. I know it's off on spacing. Is that driving you nuts? Okay, then what would I do?
Divided by -3.
Good job. Y equals 4x minus 3. That's the first equation. And then the next one, we're going to do the same thing. We're going to do as Emma suggested. Oh no, I read that weird. My tired brain was reading it weird, guys. Okay, we're going to subtract that 2x. So we're left with 8y equals -2x plus 24. Then what would I do?
Divided by 8.
Divide by 8. Yeah, are we confused about what to do, guys, or just tired? So we're left with y equals -2/8. Just tired. Okay, plus 3. I'm with you. So with you. Okay, so we have one slope that's -2/8. What is -2/8 reduced to?
-1/4.
Yep. So we have a slope that's a -1/4 and a slope that's 4. Are those perpendicular? What do you guys think? Piper says yes. Piper is correct.
Yeah.
So this is a yes, perpendicular. Because when you solve it and get y by itself, Malachi, then you can just read the slopes off there. Okay, so we got to make a perpendicular line that is perpendicular to this line that they gave us. So first I'm going to read that slope. What is the slope of the line I am given? We're almost done. What is the slope of the line I'm given?
-4.
-4. So the slope of a line perpendicular to that line would have to be what?
1/4.
1/4. And now I'm going to take that slope and my point, and I'm going to plug it into y equals mx plus b to figure out my b. Oops, I don't mix there. So what am I going to put in for y for this one? What's my y value?
-7.
Yep, because it's in the second position in that ordered pair. That is my y value. And then what about my m? Oops, why did I put a 4 in there? Nope, that's not right. What about my my m? Yeah, the m goes next. What's my slope? Because remember, we're doing y equals mx plus b. What's my slope of the new line? What slope did I figure out in step 1 that it has to be in order for it to be perpendicular to that line? What was our slope? It was a fraction. Only one?
1/4.
1/4, yeah. So we're gonna go 1/4, and then my x value is -3. So I'm gonna go 1/4 of 3, which is the same as -3/4, right? So -7 equals -3/4 plus b. Now what do I do? How do I solve for b, guys? Hello, are we there, Lucy, guys? Anybody? I just see your name, Lucy, on my participant list. That's why I said your name. We still there? I know we're sleepy. I'm sleepy too. We wouldn't multiply. That's a good guess, though. I'm alive. Okay, good. We wouldn't subtract because we're already subtracting. We're subtracting a -3/4. We got to add. Thank you. So we're going to go -7 plus 3/4. And that's a good Desmos question. Can someone tell me what -7 plus 3/4 is in Desmos? What do you guys think? What's -7 plus 3/4? Are you guys plugging in your calculator there? -6 1/4? Yeah, that makes sense, doesn't it? I like to type stuff into Desmos just because it's fun. And it's the best website ever. -7 plus 3/4. So we're going to go -7 plus. Yep. -6 1/4. Yeah, that's right. So we get a b of -6 1/4. So I have to take my new slope, y equals 1/4 x minus 6 1/4. That is what my equation would be. Does anybody have questions on that? That was a lot, I know. It's a lot of material. Especially when we're tired. Are you freaking out because it's confusing, or are you just tired? Tired, yeah. Cool. Okay, we got to talk about systems of equations. Okay, so guys, these are two. This is a system of equations. Guys, see this bracket in front? That's connecting them, saying that they're kind of together. And there's going to be a solution to that system. Okay, and the way we find the solution is we're going to graph it. And I want to show you, make sure you're awake and paying attention, because I want to show you something really awesome Desmos can do for you. Okay, make sure you're awake. Okay, so this is your system of equations. This is for your last assignment where you'll have to solve systems using graphs. So you're basically looking, where do these two lines intersect? And that is your solution for the system. So what you would do is you would just graph them, or you could go to the graphing calculator of Desmos. Go to the graphing calculator because it's pretty awesome here. I'll put the link in chat. There's the graphing calculator. Watch, let's type this in. Y equals -2x minus 6. Oops, nope, I didn't mean to do that. Cool, so there's my line. And now I'm going to type in my other one. Y equals -1/3 x minus 1. Look at guys. Guys, look. What does it show you? Without making you guess. Isn't that so cool? It graphs it for you. -3, 0. It tells us that's where that intersects. That is our solution to the system. Okay? If I wanted to see it a little clearer, I would just graph it. So -2, -6, or excuse me, y equals -2x minus 6. I'm going to put a dot on -6. Then I'm going to go down 2, right 1. Down 2, right 1. So there's my first one. Then I'm going to go down 1. And then I'm going to go down 1, 3. See, it's kind of hard to tell where they graph exactly. So I really want to encourage you to use Desmos. Okay, but you're just, when it says graph both equations and find the solution, wherever they cross, that is your solution. So we found out, according to Desmos, they do cross at -3, 0. So that tells us what the x and the y are. If we have -3, 0, which variable does the -3 go with?
X.
X, yeah, -3 is the x and 0 is the y. So you would say x equals -3, y equals 0. So guys, all you're doing for this homework is just graph both of those equations. That's it. That'll tell you the solution. But yeah. Yeah, guys, a solution is a point that is on both lines. So it's where the two lines intersect. How would you check if something is a solution? So look at this one, guys. Last question, last question. Last one. Yeah, how would you check if that's a solution? How would you check if that works? What do you guys think we would do?
Graph the lines.
You could graph the lines. You totally could. You could type it into Desmos. Y equals 2x plus 10. Let's type that into Desmos. Look, I already have them up there. 2x plus 10. Oops. Whoa, that did not work out. 2x plus 10. And then in the second one, -4x minus 1. And you could see where they intersect. And sometimes you have to adjust it. Oh yeah, it looks like that's the intersection. Yeah, Piper, that's right. You could also plug those numbers in and see if that works. Totally could do that. That's right. So we could check. We could go 2 times -4 plus 10. Does that give you 2? 4 times -2 is -8 plus 10. Yeah, that one works. Now let's check it for the other one. 2 equals -4 times -4 minus 1. So does 2 equal 16 minus 1? No, it does not work. So we would say no, not a solution. Oh, Malachi. Malachi, what? I know, this is a lot of review, but that's all I have for you guys. I know, I threw a lot at you guys. I apologize.